All right, I've got the notes for the last way to solve quadratics, which is by the quadratic formula. So the quadratic formula can be used to find the solutions to any quadratic equation without having to do factoring or completing the square. So usually this is especially useful when you have coefficients on your x squared term. So there's the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So a, b, and c are the coefficients or the constant terms from the standard form, so ax squared plus bx plus c. Note we're not including the x squared and the x. A is just the coefficient, b is just the coefficient, c is just the constant term. Because of that plus or minus symbol, we'll end up with two solutions. So when we get to our last step, we'll have to split the equation. One's doing negative b plus whatever the square root is, and the other one doing negative b minus whatever the square root is. So let's look at some examples. So since we have to be in standard form, all terms need to be on the left. So we need to move that negative 1 over. So 6x squared minus 7x minus 20. So add it across. So for this problem, a is 6, b is negative 7, and c is negative 20. So x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2a. Note that I always put whatever I'm substituting into parentheses just to help make it more clear. You do need to be especially careful with this term here, the b squared term, because if b is negative and you leave the parentheses off, it will calculate incorrectly. So negative b is going to be positive 7. Negative 7 squared is positive 49. 4 times 6 times 20 is 480 all over 12. So underneath the square root, we have 529. So the first thing we do is check to see if 529 is a perfect square, which it is 23. So 7 plus or minus 23 over 12. So this is where you'll have to split the problem. So we need to work out what is 7 plus 23 over 12 and what is 7 minus 23 over 12. So this is 30 over 12. Divide both by 6, so 5 halves. This would be negative 16 over 12, divided by 4, negative 4 thirds. So our two solutions are 5 halves and negative 4 thirds. Okay, so for the number 2, everybody to the left, so add that across. So that's 16t squared minus 8t plus 1 equals 0. So a is 16, b is negative 8, and c is 1. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a is 2 times 16. So let's see here, that's positive 8 plus or minus the square root of 64 minus 64 all over 32. So 8 plus or minus the square root of 0 over 32. Well, the square root of 0 is 0. So this is actually a special case because 8 plus 0 and 8 minus 0 would give me the same thing when I do the split step. So I don't need to worry about the 0. So it's just 8 over 32, which is 1/4. So this will only have one solution. So if the stuff underneath your square root ends up being 0, you actually end up with a single value. All right, so for number 3, bring the 6 across. So 10d squared plus d minus 3 is equal to 0. So for this problem, a is 10, b is 1, and c is negative 3. So let's see here, we got x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So negative 1 plus or minus the square root of, well, 1 squared is 1. That's positive 120. And then 20 on the bottom. So negative 1 plus or minus the square root of 121 over 20. 121 is a perfect square. It is 11. So then split the problem. Negative 1 plus 11 over 20 and negative 1 minus 11 over 20. So that's 10 over 20 or 1/2. This is negative 12 over 20. Both can be divided by 4. So negative 3/5 would be my two solutions. All right. So if you notice also, sorry, didn't point this out, these are where it says rational solutions. Rationals are fractions, which means our answers will be fractions, or if you're working in decimals, they will be either decimals that terminate, this is 2.5, or decimals that repeat, negative 1.3 repeating. For irrational solutions, in this case, that square root term will not simplify, which means we can't take the square root, et cetera, et cetera. So for this one, 6n comes across, so let's just give us n squared plus 9n plus 1 equals 0. The other thing about rational ones is that if your equation is rational, it means it is actually technically factorable if you wanted to try to factor it. Irrational solutions, if you try to, you can't factor this. There are no numbers that multiply to 1 and add to 9. It can't be done. Also, I've been actually making a mistake on the previous problems where I was always using x. The variable for this problem is actually n. So n equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's negative 9 plus or minus the square root of 81 minus 4 all over 2. So negative 9 plus or minus the square root of 77. Yep, 77 over 2. So what we should technically do is try to factor tree 77 to see if the root simplifies. 77 is only 7 and 11. There are no other factors, so root 77 can't be simplified, which means that is our solution. The root just stays. Okay, so for 5, add the 4 across, so 3m squared minus 13m plus 8. So a is 3, b is negative 13, and c is positive 8. So m equals negative b, so negative 13, square root of b squared, once again, parentheses extra important there, minus 4 times a times c, all over 2 times a. So that's positive 13 plus or minus the square root of 169 minus 4 times 3 times 8 is 96. All over 2a is going to be 6. So 13 plus or minus the square root of 169 minus 96 is 73. And once again, 73 also prime does not factor. So that is our solution. All right, so for our last one, add the 2 across, which give me negative 7. So a is 3, b is 1, c is negative 7. So r equals negative b plus or minus the square root, b squared minus 4 times a times c, all over 2 times a. All right, so that's negative 1 plus or minus the square root of 1 plus 4. 3 times 7 is 84, all over 6. So negative 1 plus or minus the square root of 85 over 6. So 85 is divisible by 5, but I don't know if that gets us anything useful. Nope, it's 5 and 17, so neither of those factor any farther. I don't have any pairs, which means root 85 does not simplify. That brings us to the end of the section.